All right, welcome to The Explainer. Today we're talking about something that goes way beyond your typical chatbot. We're diving into AI agents. And these aren't just systems that can talk. Nope, these are systems that can actually do things.
Think about the chatbots you use every day. They're amazing, right? But they're also, they're kind of passive. They just sit there and wait for you to ask them something. So what if we could flip that script? What if an AI could actually take initiative, act on its own to get something done for you? That, right there, is the whole idea behind AI agents. Okay, so here's how we're going to break it all down. First, we'll see what makes an agent different from a basic workflow. Then, we're going to peek under the hood and see how an agent thinks. After that, we'll see how it actually gets things done. And finally, we'll visualize the path it takes. All right, let's kick things off. Section 1, agent versus a predefined workflow. And this is really the core distinction. So this slide really gets to the heart of a huge shift in control. A predefined workflow. Think of it like a train on a fixed track, right? Every single step is laid out by a human, it's super predictable, but it's also really rigid. Now, a dynamic agent, that's more like a self-driving car navigating a busy city. It's autonomous, it's flexible, and the AI itself is in the driver's seat, figuring out the best path as it goes. And this quote just nails it perfectly. The key difference is whether the LLM can dynamically direct its own process and use of tools. It's not about you telling an AI to follow a list of steps. It's about the AI figuring out the steps for itself, on the fly, using the tools it has. That dynamic direction, that's the secret sauce. Okay, moving on to section 2. How does an agent actually think? We're going to introduce a really cool concept called the React framework. So, what is React? Well, the magic is all in its name. It combines reasoning, that's the thought part, with acting. The AI doesn't just act blindly. First, it thinks about what it should do. Then it does it. Then, and this is crucial, it observes what happened. That observation feeds right back into its next thought. It's this continuous cycle: thought, action, observation, new thought. That's how it learns and adapts. Okay, that might sound a little abstract. So to make it super clear, let's walk through a classic example from the research paper that introduced this whole idea. The task is simple: put the pepper shaker in a drawer. Now, for us, that's easy. But for an AI, it's a surprisingly tricky puzzle. So first, let's see what happens without that reasoning piece, with just an action-only approach. The AI is basically just guessing. It tries random things. It goes to a cabinet, it's empty. It goes to the sink, there's a sponge. It then tries to grab a pepper shaker from the sink, even though it never saw one there. See what's happening? It's just running through a list of possible actions, failing over and over again because it's not actually learning from what it sees. But now, look what happens with React. The whole process is completely different. The agent starts with a thought. Okay, I need to find the pepper shaker. I should probably check the cabinets and the counter. So it acts on that. It goes to the counter. The observation? Hey, I found the pepper shaker. That success informs its next thought. Awesome. Now that I have the shaker, I need to find a drawer. It acts again, finds a drawer, opens it, and puts the shaker inside. Task complete. It's a logical, successful plan, and it was created entirely on the fly. All right, section 3, putting the agent to work. So we've seen that an agent can think and plan, but those thoughts are pretty useless if it's trapped inside its own digital head, right? It needs a way to interact with the world, and that's where something called tool calling comes in. So what is tool calling? Think of it like giving the AI a toolbox. A language model by itself can't browse the internet. It can't do math. It's just really good with words. But we can teach it to recognize when it needs one of those skills. And when it does, it can call the right tool for the job to go get the information or perform the calculation it needs. Okay, let's trace this out with a real-world example. Imagine a user asks the agent, "What is LangGraph?" Now, let's say the agent has never been specifically trained on this. What does it do? Well, the very first thing it does is think. Its internal monologue is probably something like, I don't have this information. I need to use my web search tool. This moment of self-awareness, recognizing that it has a knowledge gap, is absolutely the critical first step. And then it takes action. It doesn't just think about searching. It actually calls the specific function for its web search tool, in this case, Tavily_search, and it passes LangGraph as the query. It picked the right tool and gave it exactly what it needed to work. Next up is the observation. The tool does its thing, it goes out and scours the web, and it comes back with a bunch of raw search results. This is brand new information from the outside world that the agent can now read and process. And finally, it closes that loop. It takes all that raw data from its observation, uses its amazing language skills to make sense of it all, and puts together a clear, helpful, and accurate answer for you. It successfully used a tool to fill a gap in its own knowledge. Pretty cool, right? Okay, final section. Section 4, visualizing the agent's path. All of these dynamic decisions can get pretty complicated pretty fast. So how do we actually structure this flow so it doesn't become a total mess? That's where a framework like LangGraph comes into play. Now, don't let the word graph scare you off. It sounds complicated, but it's really just a fancy word for a flowchart. You've got nodes, which are just the actions or the steps in the process, things like call the chatbot or use a tool. And then you have edges, which are basically the arrows connecting those steps. They represent the decisions that tell the agent where to go next. So here's how that flow actually works. The process starts, and it hits the first node, which analyzes your request. Then it gets to a critical decision point, that's a conditional edge. The question is, does this request need a tool? If the answer is yes, the flow gets sent over to the tool node. After the tool does its job, the process loops back to the chatbot node to put together the final answer. This graph gives us a crystal clear map of the agent's decision-making process. So what's the big takeaway here? It's that this isn't just some small, incremental upgrade. This represents a fundamental shift. We're moving from AI that are just passive text generators to AI that are active, problem-solving systems that can reason, plan, and actually act in the world. And that brings us to the final thought I want to leave you with. The agent we looked at today had one simple tool, a web search. But what happens when we give these agents a much, much bigger toolbox? I mean, what if they could access your calendar, book your flights, manage your email, or even write and execute their own code? Suddenly, the line between asking for information and delegating a complex task starts to get really blurry. And that, my friends, opens up a whole new frontier for what AI can do for us.